Live! There we go. Great, let's go. Okay, hello. Welcome back to another game development game engine stream. Before we get into the coding, as always, we're gonna have a little bit of a talk. Before we do that though, let me do the actual professional stuff out of the way and share my live stream. Okay, there we go. I think, yeah, that's done. Close this, close that. There we go. Everything is set up. Good. Okay, good. I think we're ready to get things started. So before we do anything else, how has your day been? Mine's been going pretty well. Had a decent day at work, I think. Yeah, didn't do much special, but kept grinding on the old game we're making, but nothing, no spoilers on that part. Anyway, anything else I need to say? Is there anything on my pre-stream list? No, okay, there's not. Okay, great. So without further ado, I think it's actually time we can get crack in right into the stream. So let me transition here to our coding setup. So we got our triangle here. This is what we have currently. It's still the same as stream number 2. At some point I'm gonna have to be more embarrassed about it, but actually behind the scenes this triangle is so very different from the one from stream 2. So that's the reason why it's taking so long. Okay, so let's take a look at what's on the list for today. First one is memory leak detection, which will be interesting to take a look at, and then we're gonna take a look at proper synchronization, making a proper fence class, making a proper signaling event, stuff like that. I'm pretty sure there's a documentation about it. Let's see, what would it be called? 9x12 hello world, hello triangle, there we go. Okay, so this is hello world samples, and there should be a link to the GitHub somewhere. Apparently there's not. Okay, Broscode, this is the one. I was looking at it. Okay, so there's a hello world. And then hello world, fiat, encoding, graphs, generic programs. There should be one that's looking at sources. Oh yeah, hello bundles, constant buffer, stray buffering. This is maybe the one we need to look at. I'm not sure. That one, or it might be this one. Let's see if it's this one. Init UI pipeline objects. Okay, just look at the other one. Maybe it's this one, I'm not sure. Okay, on it, load pipeline, create device, this is all fine, vertex shader, sample count, vertex buffer, fence event, throw it failed, H result. This might be the correct way to do it, yeah. So we might have to take a look at how we do it here. But before we do that, I want to take a look at memory detection. Now what memory detection is, in a lot of our code we call something with the keyword, I don't know if I'll be able to find, I know where I can find one. If we have a unique pointer in here, yeah, we have a keyword here called new. And these have to be symmetrical, because basically what you do with new is you ask your operating system for a bit of memory that you can use. Good, that's how we do new. But then, at the end of our program, or at the end of when we're done with that block of memory, we need to tell the operating system, hey, you can use it again. And that's what we do with the delete keyword, which is over here. And these have to be symmetrical. So if you call something with new at the end of the program, it should have been deleted as well. And I want to make sure in our code that we don't have any memory leaks, which is what it's called when you don't call delete on it. And to do that, what we can do is we can make something like a memory manager. You can get very advanced with this and pre-allocate blocks of memory and then get yourself some memory from there, and you can do all that crazy stuff. But for me, what I just want to do is with new, we're gonna allocate some bytes. And then with delete, we're going to remove some bytes. And I want to see if we, by the end of the program, have given everything back to the operating system. That's it. That's all I needed to do. We could, at the end, of course, find out what the memory is and stuff like that, but that's way too difficult. So what I want to do is, inside our CMake list, I want to add memory manager class, or memory manager files. So let's take a look in here. I'm gonna create a new text file. Let's call that memory manager. Memory operator, maybe? Operators. That might be a better word for it. And then that's gonna be an H file. Yes, and then we're gonna create two other files. Text document, which will be memory manager. Actually, 3 files, I think. So let's create all of them. Memory manager.h, yes. We're gonna create an implementation file as well, or an inline file first. Yes, which is basically a header file as well. And then a .cpp file. There we go. That's it. That's all we need for now. Good. Okay. Then 1, 2, 3, 4. Okay, we got all the things in here. We need to add them in here. So memory operate. What? Memory operators. Oh, it actually shows. That's nice. Memory manager, and then we're gonna duplicate that, .inline, duplicate that, cpp, there we go. And now if we rebuild this, rebuild selected project, then we should have it in here, done and dusted. We should see the files in here. Oh, I rebuilt the whole project. Whoops. That's fine. Did I click all? Whoops. Yeah, just rebuilding everything. Oh, okay, good. Okay, so now we got our memory files. First thing we're gonna do, memory operators. We're gonna make 2 defines, which is gonna be sound like crazy stuff, but it makes sense. So what we're gonna do is we are gonna do a define HP new. Let's do it like this. And for now, it's just gonna be new. And then we're also gonna define hdelete as delete. Sounds crazy. I'll explain what this does in a second. What is it actually gonna say? Macro is not used. Yeah, that makes sense. So let's do it like this. Like so. And I actually like that it's all lowercase. So maybe we'll do it like this. But for now, let's just keep it like this. Makes sense? Now what we're gonna do, very important, we're gonna look at all of the news in our project, in our solution. And we're gonna replace them with a space, please. And we're gonna replace them by this HP new. And I don't have that many, I think. So we got one here. It's gonna be HP new. And then it's gonna be HP delete. Might be a more interesting case though. Might be more difficult to do this one. We'll see. We'll figure it out. And then we had more, right? That was that one. We have this one, so this is gonna be HP new as well. And there's gonna be a delete somewhere in here. Oh, there is, no, not. Oh, there is, there we go, I thought so. HP delete, there we go. Next one. So that's that, that's the define, cast into new version, that's fine. And then this one. It's gonna be, oh, do I delete this? I don't. Interesting. Okay. So we might actually have a memory leak already. That's gonna be interesting. HP new. Now this should just compile without issues. Maybe the array one is a bit weird. I don't know. We'll need to take a look at that. So what this macro is gonna do for us is it's gonna keep track of our memory count. It's the only thing it's gonna do. Right? So that still works. And that's the only thing we've done. Now we can say new and delete are actually banned from our code base. We can't use that. We always need to go through the HP new and the HP delete. Very interesting. I think so. And then inside the memory manager, okay, what we're gonna do. Oh, we actually don't need the inline file, I think. Oh, well, that's fine. We're gonna do a pragma once. And then we're gonna make, technically this needs to be a singleton. Let's do a namespace HP, and then we're gonna call it class, or actually class. It's gonna be completely static class, so let's just make static functions for it. I think static increase ref byte count, mem count. Actually, yes, let's put them in a class. Okay, so let's put a class memory manager. Why did you do that? There we go. And then we're gonna do a public void increase mem count. Boop, go, and then we're gonna do void decrease mem count, and these are both gonna be static, and this one as well. And then in private, we are gonna have a static long, I think. Let's just do a uint64t for now. In that header, mem count, byte count. Allocated bytes. Allocated bytes. There we go. That's all we need for now. So this can go. We don't need that anymore. We got all of this. We have this one. Now we just need to include this. And then at the end of our program, we need to, oh, it's gonna be interesting. Because everything that's made on static time also needs to do that. Oh, this is gonna be interesting. Very interesting. Okay, no worries. We'll see what it does. So inside our memory manager, this one, we're gonna include, of course, our base file, and then we're gonna do void HP memory manager increase. The only thing this is gonna do. Okay, interesting. We can make this templated. We can also not make it templated. I think it's better if we make it not templated. So for that, we're gonna just do an uint64t bytes in here. And then the only thing this is gonna do is m bytes, allocated bytes, plus equals bytes, right? It's the only thing we're gonna do. And then in here, we need to make sure that we actually do an uint64 bytes in there as well. And then decrease, same thing. Nice. And then we also need to do this. Copy this, paste it, decrease. There we go. We got it. Okay. Now what I want to do is make a report function. So we are gonna make a static void report function. memory leaks. The only thing this is gonna do is it's gonna assert when we have memory leaks. So in our CPP file, again, void report memory leaks, HP assert, which is my own runtime asserts. And then we expect allocated bytes to be 0, memory leaks detected. Oh my god, there we go. That's all we need to do. And then we need to call this function. And when do we call this? Well, we can technically do it on the destructor, but that's sketchy. So at the end of our program, we need to call this basically as the last thing gets destroyed, which is annoying. And that's where the annoying part comes in, because we need to start tracking and stop tracking, basically. This is only going to work for runtime objects. Everything that's allocated with static memory, that's in static memory. You can't use static memory. Yeah, that's true. But we need to make sure that we call this after everything else is done. So if we go to our main function, which is in game, application, right? Basically, in shutdown we should report it, and it's run, and in setup we should do it. Only issue is application has all of these objects, which will also be counted. So it's gonna be interesting how to do this properly. We can do it here as well, but then again, this is static data. So the only way I can see that we can do it is we make a memory manager here. Right. And then we report it later on. And for that, only thing we can do is make a singleton. Because we need static. No, technically we don't. Yeah, but it's best if we make a singleton, basically. So we can make a singleton. It's gonna be interesting. I don't want this to be a singleton though. But sure, singleton it is. That way we don't need any static memory. Static function calls. So these don't need to be static. Okay. But what we're gonna do is we're gonna do memory manager reference. Right, and this is gonna be get instance. The only thing it's gonna do is return our pointer, and that one is also gonna be static. This one technically doesn't need to be static. No, this one doesn't need to be static anymore. But we are gonna have our static memory manager pointer in instance. Okay. Now, interestingly enough, I want this actually on the stack, but I can't. It's gonna have to be a pointer, which is annoying, because this is gonna be no pointer. There we go. Okay, we can't assign it here. Fine, sure. And then we're gonna have to get instance. We have to kind of implement that. Oh yeah, first of all, private destructor, private constructor. We can't create it. Equals default, by the way. Get instance. We need to implement that now. Let's do it at the top of the file because it's the most important function. Memory manager. HP memory manager get instance. Oh yeah, we can do it like this, I remember. Return instance. That's a way better way of doing it, then we don't need to keep track of it. Not like this actually. I think that's how it works. Member function can be made static. It is static. Oh, it's not static. Static. Okay, this should work. So what this is going to do, it's going to create a static instance for this function, which is going to stay alive. I think. Actually, let's look it up. C++ singleton. Singleton. Because I'm pretty sure we have the pattern and it's designed properly at this point. This one as well. 17 years ago, that's too long ago. Actually, maybe it will have the updated one. Okay. So, naive singleton. We have a static singleton pointer, like I said, right? You can't... Yeah, we need to delete, copy, and move ups. That's actually a good point. And you can't... Yeah, you make that. Then you make a get singleton. This is a safer way to create an instance. Yeah, dangerous if two case. Yeah, that makes sense. Thread safe singleton. Singleton. With a mutex? Oh no. Class singleton, static singleton object, return object. There we go. This is the proper way of doing it. Last updated not that long ago. Yeah. This is the correct way of doing it, I think. I'm not sure if this will guarantee that it will exist. Using the Mear singleton, which is automated. Yeah, static instance. Yeah. That's when I first requested this installation because the object created only when needed. Thread safety. Okay, so this the Mear singleton is thread safe, so that's the reason we actually want to worry about it. And this doesn't use no, so that's perfect for what we want. And I think probably this one will show it. Yeah, static instance. There we go. Can't be destroyed. Initialize on first use. Perfect. That's what we want. And we can plop it in the header. I don't know if that will do anything, but that's not something we need to worry about right now. I like it more here for the moment. So we got all of that done. Memory manager default, and then we also gonna delete, copy and delete, move. Can't copy a singleton, can't move a singleton. So memory manager, there we go. Properly deleted. Done, done, done. Singleton, check. Good. Okay, now what are we gonna do with this? This is gonna start. We need to clear this at some point, right? Oh, this is gonna be annoying. See, this is where... Oh, we can easily do it. Ah, figured it out. Okay. So we don't need to do this. We just need to do this. Oops. That. And at the end, we are gonna do memory manager. Get instance dot report memory leaks. There we go. That's all we need to do. And now I know there might be a memory leak, but actually we've not implemented it yet. Because if you go back to our memory operators file, oh, and we can delete that file. So let's actually do that. Let's delete this. I can't delete it from here. Okay, fine. We don't need you, so delete. And then inside the CMake for you. You can also go, there we go. And then memory operators. Okay, so we got these two defines. Now what this is gonna do is we're gonna have new whatever comes after, but before that we actually need to increase our ref count. And to do that, we actually need to know what the object is. So I need to do this. Will the delete give back how many memory, how much wait, whoa, hold on. Does new and delete give back something? Yeah. See, this HP new is also annoying, but we need to figure out how much memory we allocated. Interesting. Very interesting. So we need to call memory manager here, definitely. Which is gonna be HP memory manager. And then we're gonna have to increase. No, get instance. Like so. And then it's gonna return increase memory count. But we need a value in here. And same here, we need to decrease. So we can already call it with 1, but that will not work. Well, it will, but technically let's actually just call it with 1, see if it compiles. And then we'll need to figure out how many bytes we actually allocate per use of new and delete. Okay, so oof. Yeah, okay. So we got a lot here going wrong. Because we don't include memory manager. Okay, so in memory operators we need to include memory manager.h build. Okay, we're still not there. Get instance, did I not? That's a reference. Okay. Yeah, shut up. I know I'm building wrong. Ah, interesting. Yeah, kind of probably need to wrap it in a function, shouldn't I? Yeah. Alright, so HP new, we actually want to wrap in a function, and that will make it a little bit easier, I think. Because we need to figure out how many bytes we allocated. But sure, let's make it compile first. So memory operators HP new is gonna be this, and then we're gonna do data. That's fine. New data. Right. Like so. No, it's still wrong. Let's we need to figure this out on our own though. Interestingly enough, that's very hard to do. Because this needs to be basically a function call and return this, but that's also not what we want to do. Okay, I think we actually gonna look at memory operation. C++ find memory leaks. Let's do a detect. No, not detect. Track memory allocation, memory usage. There we go. Oh boy, no, that's not what I wanted. Allocations. There we go. In the C++, oh, it's gonna be great. Take a look at it. I don't want a tool, I want to write my own one. Yes, I know all of that. Memory tracker. Okay, this is gonna be a GitHub. This one might show us how to do it. Files, memory tracker. Okay, let's see. How are they doing it? Package. That's a demo, so let's look at the include, and it's gonna have a memory tracker. At some point, you're gonna have to overload new. Void report, test overloads, template. Ah, they just overload. Yeah, I didn't want to do that. We could do that. That is a way of doing it. That is one way of doing it. I didn't want to go that route though. Maybe this one. This is also gonna overload the... It's not. Okay, that's different, but sure. I know we don't need to overload the new and the delete, so that's what I would like to do. But then we need to do some define idiosyncrasies. I'm not sure if that's worth it. Oh boy. Go back to the code. So we got this now, right? And we do need to do this. But that doesn't need to be there. This will always work. I'm pretty sure. It's the new that's the issue. Which is why we have this. I mean, the easiest way is to overload it. But I don't want to overload it because then I would also track memory allocations in third-party libraries, for example, which is not technically what you want. Not technically what you want. Right? Okay. Let's figure this out. We want to do the new keyword. I mean, I can just return that, kind of. It is just a call to something else, though. Because the easiest is to just say increase that, do that, return that exact line, but you don't know. Right, you don't know what it is. Oh, this is so annoying. We're so close yet so far just because. Let's get it back up. Where's the core lip? Unique pointer U. Yeah, so basically what this does, HP new, why can't I resolve that symbol now? It's a memory operators, right? Okay, let's get rid of that. So now it should be able to resolve that symbol. Delete. Get instance. Decrease mem count. Okay, so it will be helpful that we actually get the correct instructions there. That might help already. So then this one will always work, right? So it will just call decrease mem point and then delete. That's fine, right? This expansion preview though, however, it will return. Why return? Oh yeah, unique pointer of that and then that. Oh god. Are we just gonna do a function? We could just do a function. I don't know if that will work though. Yeah, I know it doesn't work. Okay, so what this does is we have new here. What that? That's unfortunate, eh? Because we could do like this, right? We could do new data, and then we are going to write something here, which will be just a function call, basically. Which will be an auto function call. We just need this. We just needed to do both, right? So maybe this will work if I do this and then do that. And then hope that this works. Oops, that might do something. I doubt it. I can't even resolve the symbol now. What did I do wrong? Is it the return keyword? No, it should be fine. Do data. No, it will just make a new lambda, doesn't it? Yeah, I'll just make a new lambda. Oh boy. Maybe I can get around with a comma sep. Okay, let's, because I know there's something like a C++ comma operator. What does the comma operator do? Where is my CPP reference? Okay. So comma operator. What does this do? Not the function call, the comma operator. Built-in comma operator. Comma operator, the expression is evaluated, its result is discarded. Although, whoa, this might be exactly what we need. Hold on, where did it go? No. The expression is as if it has class of it, won't destroy until the end of the continuous, and its side effects are completely before expression 2 begins. Okay, so that might be exactly what we need. Maybe. Let's see. We might get away with this after all. Okay, very obscure features in C++ language. Let's just do that. And then this. And then that. And then we don't need this. And then it's gonna still be HP here. Okay, let's see what this is. I mean, I have hopes, but they're not high. What this does is it comma separates that, and then it does that, and that should actually work. I don't... we'll see if it compiles. I doubt it. I doubt that it will compile. There we go, that's a bunch of red. Okay, HP new undeclared. Oh, it might actually be these. So let's actually, like so. Okay, it might not work. Damn it. Oh, I got my hopes up. Oh, that's unfortunate. That's very unfortunate. I mean, we could just do that. But that's also annoying, eh? Interestingly enough, I'm pretty sure I can figure out how to do it. But I don't know where to look. Damn it. C++ memory allocation tracking without overloading. We can do the journal, we can take a look at it. Actually, let's open this, close it. Ah, shut up. Do we have the code? Of course we don't. Okay, great. Let's see what this actually... Let me actually put it over here, do that. Let's figure this out. I'll see if that works. I know how... We have an appropriate thing here. I don't want to overload. That's unfortunate. This should have... I was hoping for this. Okay, so we got introduction here. Allocations, yeah. Oh, he's overloading it. Oh, you. It's overloaded, eh? Unfortunate. Very unfortunate. Okay. I had high hopes for the map for the com operator, but I'm pretty sure I had the feeling it wasn't gonna work. Oh boy. We should be able to do this exactly this. Damn it, how can I not figure this out? It shouldn't be that hard. So the delete definitely works. I mean, we just need to figure out how to get the data in there, but we can actually look at the new and delete keyword. New keyword. Mm-hmm. Dynamic arrays allocation. We should also have the delete keyword here, yes. Mm-hmm. It's gotta be one of those streams, is it not? I know for a fact this is possible, because I'm pretty sure we use something similar in my day job. But I can't figure it out. Because we need to do something for the new to work. I mean, the easiest way to get around that is by overriding the new keyword. That's what I don't want to do. Because we can basically just call that. I was hoping this would work though. I'm stumped at this point, and I do want to do this first. As we do have like this all done, I'm also not feeling great to continue the stream without fixing this. I know for a fact it's possible. Oh my god. Man, this should have been so easy. We can still just overload it, but I don't want to do that. The downside of overloading them is that if we have any external libraries, they will also use this memory tracking, which can lead to memory leaks in parts of code that are not yours because you've imported a library memory leaks, which is very possible. Which is the reason I don't want to use it. I just want to track if my code is safe. And also it could be that they have their own set of memory operators, right? And then they will work with that and yours will work with this, and you know, it's a mess. You should never overload your memory operators, because if anybody wants to do it, you can only do it once, basically. This, it's so simple. Why does this not work, right? It's because this returns things. And it's even worse. No, I can't figure it out. I can't see a way around this at the moment. It's definitely possible. I thought this was gonna work. Because if we read the documentation for it, well, let's actually... We had the documentation for this, right? Super plus comma operator. Other operators, this is the one. Okay, so... Comma expressions have the following. In a comma expression, the expression is evaluated and is called, although it has a class type, it won't be destroyed until the end, and its side effects are complete before the expression begins. Note that the user define cannot guarantee sequencing. The type, value, and value category of the result of comma is exactly as the type, value, and value category of the second operand. If E2 is a temporary expression, the result of expression is a temporary expression. If E2 is a bit field, the result is a bit field. It has to be an expression? Nah. It's unfortunate. Conditional operators, overloads. Oh, that's unfortunate. Track memory without overloading new. You can track memory by using preprocessor macros, custom allocators, or built-in set sizes. That's basically what I'm gonna do. This is with overloaded new. Without, please. Gonna have to try. Micro definition. Okay. This might do it. No, that's define new. It's not what you want to do. Define. No, no. I had hope for this. Oh, that's just this. Oh my. Where did you get the debug new? It's just. Oh no, it's redefining new. Oh my god. Struggling. How can I do it without overloading? What am I missing? Oh boy. They all say to overload it. I don't want to do that. This is also gonna be with overloading. Makes sense to do with overloading, right? Because then you can track everything, but I don't want to overload it. Okay, fine, overloading it is. Can we do it with overloads? Good. It's just malloc and free, I guess. So operator new. Okay, so what do we do? New. Oh, we can align as well. Fine. Okay, so we're gonna overload it. Fine. I can't figure it out. I don't like that, so we're gonna do hbnew. I will still keep the hbnew though. It's very important to me. Just because if I do figure out a way of doing it without overloading our new keywords, we can actually do it. That being said, no, we're not gonna keep them. No, we can't keep them. Okay, that makes sense. So we're just gonna do that. Just gonna do that one as well. And then the delete ones. Where's delete, 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 operator delete, these two. Delete and delete. Do we need the no accept version of the... I think this is just fine. And this one as well. Oops. And these two should be fine. And then we'll need to implement them. Ugh. Let's just do it this way. Return. That. But we're also gonna do memory manager. Get instance dot increase mem count by counts. Wait, this is just, hold on. If we go to this, just have a count. Oh, hold on, give me number 2. Oh, wait, but this is a new with that, so that should give us 2 sizes. Right? Huh? That's weird. That's very weird, because, I mean, sure, but then... Fine, we're gonna do an inline. Yo, what the hell? Something is breaking my... Okay. Whoops. What the hell was that about? We don't need that. We don't need you either. Pointer. Let's just do 1 for now. Put a new, that, delete that. Okay. Now we're gonna have to replace all of these back to new, which I don't like at all. I'm questioning my... I mean... Okay. Non-member operator. Okay, they can't be inline. Fine, sure. Yeah. Non-inline. Sure. Come on. There we go. It is compiling. Almost. Oh, they're recursive now? Whoops. Okay, so let's just do a malloc then. Which will be bad. No, we can't do that. This is not a good... Okay, so we can do malloc and free, I guess. At least for this one, I know for sure we can do malloc and free. But then actually, we have the C++ memory tracking. Let's just see what we can find. That's not helpful. I don't want to see that. I don't want to see that. This one will have it overloaded. C++ overload new this one. We can do this. I'm not asking AI, don't worry. Well, I mean, I don't want to ask AI. No, and that's... So that should be a different one, right? Yada yada yada. This, yeah, I don't care about that. It's also not what I was looking for. I need to make sure that we can overload it correctly. That's the one I have open. But this shows an example of how to overload it. Which just does to a malloc of that size. So let's just do that as well. But I guess that's wrong. I'm pretty sure that's wrong. Why is find open? Let's put standard in front of it, because why not? I mean, it's gonna work now. That's a lot of... It's a pragma once. What do you mean? And that's why I also don't like it. Oh boy. Okay. Doing this. Memory manager. Just paste that in here. And then that's weird. Now we have all of those complaints. Anyway, copy this again. Hello, hello, hello. Welcome to helping me figure out how to do memory operators correctly, because I mean, I don't want to overload them. I really don't want to. It's so bad. So I want to do defines. I'm gonna do HP new again. Or just gonna do it as new. And then define HP delete. As delete. There we go. And then we're gonna once again find new with a space. Elements, this is gonna become HB new. And then another find you. We're definitely gonna go. Another find HB new, that's already correct. Do it capitalized, please. Match case. You. Gonna be HB new, definitely. And then you definitely gonna be HB new again. And then that's all fine. And then delete, same thing. Space. Gonna be HB delete. And then this delete endpointer is also gonna be HB delete. Okay, so the delete is very easy. We can figure that out very easily. We can just say HB memory operators, memory manager, get instance, oh come on, get instance, boop, dot decrease mem counts. Let's do it by 1 for now. That's that. The new, very difficult. Well, let's actually see if this works already. This should compile now. Count. That won't compile. Now it should compile, but I think that was too late. Yep. So let's stop. Recompile. Oh boy. Okay. So I've explained this before, but the reason I don't want to overload just the global ones is because that would be for every single library we have, which means third-party libraries as well, which can have their own ones, but can also already have memory leaks. So if we're detecting those, that's actually bad. Okay, that works. So if we run it now, we should get our application, so that works. We still got our triangle. If we close it now, we should get an alert saying we have memory leaks detected. And we can actually do better than that. Where's my memory manager? Here, we're gonna say this amount of bytes. And then do that, that's perfect. Then exclamation mark here. Why is you, why, what? Okay. Anyway, where am I from? I'm from Belgium. Okay. Okay, so I got a triangle open on my second screen now. So if I close it, we get this and we say, hey, look, there's 11 bytes leaking. That's technically not correct. It's 11 memory allocations. Well, we're doing 11 deletes at the moment, which is correct. But now we need to figure out how to do it on the new operator as well, which is a bit more difficult because this returns something. And I was thinking we could do with a comma operator, but apparently not. So we need to, I don't want to return a function. That's gonna be so annoying. But we could technically do that. I mean, we could just do a void pointer alloc mem function like so, and then HP data. See, the issue with new is that new already has arguments as well because it calls the constructor. Right, so it's gonna be difficult to do either way. And then we're just gonna return a void pointer, do size stay, yeah, and then we're gonna do hp-mem, right, like so. And then we're gonna do return malloc is wrong. Gonna return new size, I think. But this needs a type ID. Yeah, that's annoying. This is definitely possible. Also, it should be increase. Right, it's definitely possible to have like a function do it. Because basically what we have now, we find any of these, no, not this. Find any of these, that's the unique pointer. This one might be, no, that's also not a great example. Is there a good example? No. Well, this is the best example we have, but we do HP new, and then we immediately create something here with an object. Right, so that's gonna call some kind of new constructor. I just don't know which one it will be. Actually, let's check. And we do this, and then we can say which one is it calling. Operator new of size t, but that's not right. Like, we definitely need to do this. Definitely need to do this. Because we need to know this information. Right, so then we can, oh, we can actually do a little bit of, yeah, okay, so then we do HP data, we can do ogc-mear, it's basically gonna be just call that function but inline it. But that's so weird to do. Ogc-mear, size of data. Maybe that works. Not sure. It's not gonna work, is it? Boy. Like, the closest I got was this. If we do this, and then we do that here, and then a comma, and then new, and then data, like so. Come on, learn to type. There we go. That's very close, I think. Because for these, wait, where was it? This one? I think that might work. But we do need some kind of, that one needs to go. There we go. And then this should work. I'm not sure if that's all of them that will work. These probably will not work. Yeah. So for now, let's actually just do new here. And then there was another one. You will also not work. Let's call new here. Let's compile, see if it actually works for that. Oh no, it's Lee. Oh no. And that's a bunch of, there we go, yeah, bunch of compile errors. That's perfectly, yeah, that's what I expected. How do I not know how to do memory operators? At least this works. The only issue is it doesn't do anything, and we just get memory leaks. There we go. So if we run it now, yeah, and it should assert, and we still got 11 memory allocations, not bytes at the moment. Ah, boy, okay. How can we trick the compiler in making this? Could we do some trickery with defines here as well, actually? Maybe? It's hard to do. The reason I want to do this, because we can also do like a tagged, right? And then we can put a tag in here. But, I mean, we need to get this correctly, or at least to be able to correctly get the counts. It's just gonna be incredibly difficult for some reason, because new returns, it's gonna be difficult to do in a define, I guess. I know it's possible. Just don't know how yet. Technically, could we do it something like that? No. We basically need this statement to be executed but ignored. Which is kind of impossible. Come on, think of something. I technically can figure out how to do it at some point. Oh boy, what? This is the... I mean, this is never gonna work. Right? Yeah. Because the issue here is that we will assign it. There should be a simple way of doing this. Hard to do. It's gonna be, I mean, horrible that I can't figure this out. I'm mad at myself for it. There we go. This should work. I should definitely be able to pull this off. But I can't. So yeah. I mean, we've been stuck on this for so long. I think I'm just gonna call it here. I have a source somewhere, but I can't find it that does it exactly like this. So I'm gonna try and figure it out by next week. And then we can figure this out, because I'm getting frustrated. We're not making any progress. I'm gonna call it here. Again, bit of a scuffed stream. Hopefully next week will be better. Okay, where's the ending button here again? Oh, there it is. Okay, so hope you still enjoyed me struggling a bit. I promise next week we are actually gonna make some progress. And we can't figure this memory stuff out. We're just gonna leave it like it is. We're gonna overload our new and delete operators like a pleb, and then continue working. But yeah, that's about it. I hope you enjoyed, and I'll see you next week. Goodbye.